The UART protocol is the simplest and one of the most used protocols you can use in your microcontrollers. UART stands for Universal Asynchronous Receiver Transmitter. It is designed to be a hardware module that provides support for serial links, serial ports on many processors. It is compatible with the RS-232 format that was traditionally used to create a serial interface on PC, Mac, or Unix systems. The basic idea of a UART module is to provide parallel to serial and serial to parallel conversion. So you will basically provide your information in the parallel as a bus to your UART, and the UART will take care of the serialization on the sender side and deserialization on the receiver side. It will also encapsulate this data frame with a start and a stop bit in order to create and being able to transfer the information and resynchronize on the receiver front. It can add a parity bit in order to guarantee data accuracy, and the data transfer can be selected to be multiple speeds. This is what we call the baud rate, and the baud rate can be between 2,400 bauds per second up to 115.2 kilobauds per second. A baud is basically the number of bits that you're able to transfer per second. On the microcontroller, this UART module is supporting several interrupts as well to tell you when you receive some information or when you have been able to transfer successfully some information and you need to feed the module even more. Let's review what the protocol looks like. The RS-232 specification tells you that your data is submitted as either 6, 7, 8, or 9 data bits. This needs to be selected as part of your UART module. And this is going to be framed by a start bit and a stop bit. Additionally, you can have an additional parity bit that is used to compute the parity of the complete word. That creates a full frame that corresponds to your UART packets. The processor that we're using, the STM32, is using logic levels between 0 and 3.3 volts. While in fact, the initial RS-232 specification indicates signals switching between plus 12 and minus 12 volts. So this is why we're not saying that a UART is actually implementing an RS-232 protocol, but just say that its signaling is compatible with the RS-232 protocol. The to make it compatible, fully compatible with the RS-232, you will need to use level converters that readily exist on the market, like the Maxed 3232, that will take the signal between 0 and 3.3 volts and convert that between plus 12 and minus 12 volts. It is worth pointing out that the RS-232 specification also mentioned which connector you need to use for this protocol, a DB9 connector in particular, which is what was used in motherboards a long time ago on your computers. The start bit always starts to pull down the signal line from 3.3 volt or the logic level I to 0. That will indicate to your receiver that a new frame is going to be transmitted. After one time interval that corresponds to the frequency of the baud rate, you will start sending out the serial information from D0 to D7 or more if you decided to have different data bits, parity and stop bit. The stop bit being a signal that will stay at 1 for one complete period. In order to set up your UART peripheral, you will find many registers as usual. You will find some control registers. This control register will be able to set up the various functionalities of your UART. Interrupt enable bits, data format control bits to select which frame format you need to use, and so on and so forth. You will have your receive data registers and transmit data registers that will be used as scratch space when you want to send an information or when you receive an information. Those will be your input and output registers you'll get access from your processor. Finally, you will have a UART baud rate register. This baud rate register will set the division ratio that you want your clock to be divided in order to implement the baud rate. Selecting the right division ratio depends on the final baud rate as well as the maximum for the frequency of your system clock. Last but not least, some interrupt and status registers will be used in order to understand the current status of your UART module at runtime. What happens when you're receiving some data? How do you know when your UART module has properly received a byte of information? Well, you have two options as usual. The first option will be to watch the flag in your status register using a polling loop or polling request. If your flag is equal to 1, you have some data available to read. Or you can also configure your module to trigger an interrupt to your processor and write an ISR, an interrupt handler, that will be able to read this data and store that in your buffer of choice. The bits that will be received will have to be read from the receive register and stored somewhere else in order to free up the receive register for a new data to come in. How does a UART receiver work? As I said, it's a fully asynchronous communication, which means that no clock is provided. If no clock is provided, my data will be coming at a fixed time interval that depends on the baud rate. However, I still need to resynchronize the phase of my internal clock between the receiver and the transceiver. In order to do that, the main principle is to use oversampling. The receiver is going to oversample the baud rate, and we'll start counting basically after at the beginning of the start bit, and the goal of this oversampling is to latch the data more or less in the middle of a clock period. That way, the error is only the value of one period of the oversampling rate.